Hello everyone, welcome back to my channel. So today the topic that we're going to discuss is threads versus process. So first of all, let's see examples where we can understand. So let's say we're talking about a word processor. So word processor or any other application is considered to be a process, whereas the things that are happening in these applications are threads. For example, in word processor, it takes input from the data, takes input from the user, and it also does auto formatting. So these two, that is taking input from the user and doing the auto formatting, are threads, whereas this word processor as a whole is a process. Similarly, let's talk about an example of a music player or VLC. So music player. Now in that, it does what is, first of all, it plays music and it shuffles the playlist as well. So it's doing both of them together. So playing music and shuffling the playlist are threads, whereas this music player running is a process. Now let us understand the difference between two commonly used terms when we're talking about threads or process, that is concurrently and parallelly. So what's the basic difference between concurrently and parallelly? So concurrently. So basically what happens in concurrently is that when one process or thread is finished, then immediately we start another one. And that has really assigned time slots in which they run. And in parallelly, what happens is that a lot of processes or threads are running at the same time. So when do we get concurrently and when do we get parallelly? So concurrently we get when we have only one processor, and parallelly we get when we have multi-core processor or multiprocessor. So when you have multiple processors, then we have parallelly running, and then when we have only one processor, then we have concurrently. Now let's move on to understanding what the most of the modern days apps use. So first of all, most of the modern day apps use multi-threaded processes. So basically, like we talked about the few examples such as word processor, wherein it was multi-threaded, as we had auto formatting also done, and we had the taking input from the user work also being done, or the media player where the media is also played and the shuffling is also done. So they are the various examples that we could talk about of the applications that use multi-threaded. Now moving on to another very important thing that we need to discuss is the basic differences between threads and process. So first point that we need to discuss in threads versus process is that it is faster to create or terminate threads. Now what happens basically is that a thread is easier to create or terminate because it is within the process. So we don't need extra work or outside work to be done. Now next point is that when we have multiple threads in a process, we have these 3 points. First of all, that they share same address space. Then they are easier to communicate. And finally, their context switching is easier. So basically, when we're talking about the threads in the same process, now we need to understand the difference here, that it's not about various threads. Like for example, if there are two processes and you are talking about a thread of the first process and a thread of the second process, then this is not applicable on it. This is applicable only if we're talking about the threads in the same process. So first of all, that they share same address space. So since we have a process, so they have the same address space. So that makes it easier for us to go to those threads. Now since they have the same address space, it is easier for them to communicate as they are very nearby. And that's the same reason why context switching is also easier in them. Now moving on to the third point, which is basically considered to be a summarization of these points, that threads are lightweight. Now since we saw that these three things are done, so it means that these threads must consume less resources. Because of these points, we can easily see that since it shares the same address space, we do not have to like create a process, terminate it, and then create another process and terminate it, and then clear the cache, etc. That's not to be done in the case of threads. That is why threads are lightweight, they consume less resources. And that's it for this video. Let's meet in the next one.